agenda is to understand what is DevOps and what makes it different from other, culture and other things we usually see in the market, and how that affects a business, and also the importance for the new members who are coming into this IT sector. So we'll walk you through all these things related to DevOps. We'll also walk you through the career map and key learnings we had through this discussion. Okay, so why do we need DevOps? That is something which we need to understand first. So we'll focus on that first now. Traditionally, the ops model which we used to have was not good enough to keep up with the current demand, or current technologies, and current industry standards. So one thing is like the release cycles, used to be like 1 month or 2 month earlier, but right now it happens every hour, or probably in a day we'll have one or two deployments at least. In a day we'll have that. There will be a lot of infra changes daily happening, and the user expectations for the uptime is kindly that is going up like 99.99%. uh, so the old traditional models are not working anymore. We have to make ourselves ready for the faster environment. The technology growth is there, so we have to focus on that. And earlier in the day, reliability was a question. That's how Google introduced SRE, or the site reliability engineers. That function helped the teams to focus more on reliability and performance, also on security as well. So that is how the SRE came in. We still have SRE. We have the managed services enabled with SRE. So that is how the whole industry is moving forward. So DevOps is also part of that. Reliability is also part of DevOps. So business keeps fighting with the same incident again and again. So without uh, you know uh, you know we have to make customers happy. So for that, reliability and the performance part is very important, and we help them using DevOps culture. We focus on that. Then there is a scalability issue, or the poor foundational problems that is mainly focused on why we use a particular set of servers, or the proper deployment methods. If we are not using that, or if you are not looking at the limits, the performance limits, or if we are having poor monitoring systems, we will be blind when an issue happens there. So everything revolves around automation, especially in the scalability part. DevOps culture will help that. DevOps and the SRE and the platform engineering, which will help in focusing on performance, scalability, and the automated deployments, and everything will be automated. Likewise, like I said earlier, observability is also it's not an optional thing anymore. It's a mandatory thing, and we have to focus on how to get the logs, how to get the matrices, system level matrices, the traces, the application performance, synthetic checks, run like real user monitoring systems. So everything is required. So this will help us to if there is any incident, or any particular damage happens to the system, we have to go back and look at the traces, logs, and matrices to understand what really happened, and how we can avoid this in the future. If this is not there, we are going to, uh, the customer experience is going to affect, and that will not help us to move forward um, in a very smooth manner. So observability is another thing which is part of DevOps. And then there is another misconception that everybody from the private clouds, especially in not cloud, in on premises, moving into private clouds like AWS, Azure, and all, and public clouds. And they think that when they move from their you know uh, uh, the local machines and into cloud, that everything is magically resolved, especially reliability and performance. But that is not true. If there is a issue in your current existing legacy systems, we have to fix that, redesign everything from scratch, and lift and shift might not help you. So that is how and where this DevOps and the platform engineering comes in. Everything will be redesigned, including pipelines, automation of the infra, proper governance is set where we control everybody's access, who should make changes in production and how it has to be implemented, whether it is having the best practices, or is it just the platforms? That's the question. So will it help if we migrate to AWS? No. Or will it help if we migrate to Azure? No. It helps only if we have a proper architecture. Redesigning is, if a problem is there, then we have to have a solution, and that might happen only if we have a proper redesign or a solution. So that is how we come from the basic traditional uh, operations method into DevOps, where we communicate between all the teams, including development, quality assurance team, the delivery team, and every team will be integrated together. The IT operations team, the infra team, and the managed services team, everybody, the SRE team, everybody will be working together to achieve the best output. That is what, in short, DevOps is. But right now we are also seeing that DevOps is moving into platform engineering, which is coming into place because of the scale. As companies grow, they cannot allow every team member to reinvent the same pipeline, the same infra modules, or the monitoring systems or the best practices they have implemented. So they'll have a standard. This should be enforced across the systems. There are different, there will be different projects or different engineering teams there. So this has to be enforced among everybody. So that's how the platform engineering coming into the picture. And this will also help the business. We'll come again to that topic once again in the later stage of the session. So let's talk about the evolution of IT operations and the project management. We started from the waterfall method, where everything seems to be sequential. So every change will go from like 1, 2, 3, 4, and the changes will be gradually moving from step one to step two, and then to the end step. But unfortunately, that you used to work well in the early ages, but right now it is not acceptable because of the fast moving, changes, the features, the hot fixes. Everything has to move in a faster deployment cycle. So this will not help then. So we moved into the agile methodology, and that's where we have the iterations, like sprint models every 2 weeks or 1 week sprints, based on what is actually required. This enables flexibility and also, helps us to introduce, faster, development cycles and improvements, as well as bug fixes, and we can introduce new features in between. So that's where the agile comes in. But later then we decided to have development team and the operations team, along with other team members like SRE, QA, and all. We have introduced DevOps culture, where everything is integrated together to make sure the development cycles are improved, everything is automated, the collaboration and the integration between the team became more transparent, and everything became reliable, including the software, the testing, cycles, and everything became more reliable and efficient. Okay, that's where the DevOps culture comes in. And we also have the SRE part. That is where the overall efficiency, the performance, and the reliability of the systems are managed. So the SRE team keeps the system reliable across the clock, 24/7. The team is really working towards making the system reliable, efficient, and also secure. Okay, this is how the IT operations evolved over time. Now, uh, if you look at DevOps, there are different stages. We have a loop, like an infinity loop where we used to see everything like plan, code, build, deploy, test, and the operate and monitor, and we continue that cycle again and again. So that's how the DevOps culture, or the DevOps the loop is considered to be. So they start with the planning stage, where we have a particular set of features or product which we want to deploy into a particular set of infrastructure, or particular architecture will be there. So we'll have to define that. First, we'll define the project, or the product features, and then we'll write down the code required for that. These will have to be version controlled. The security should be there. The code should be evaluated. Code quality should be evaluated during this process, and everything happens in this plan and code stage. This is a smaller version to make sure everybody understand DevOps clearly. So there are even broader terms and things which is required to understand what DevOps and the culture is, but I'm not going that deep into it. For now, this is purely focused on newcomers, so that everybody can understand what this is DevOps is, and how and the importance of DevOps. Then gradually we move into other stages. Um, Okay, so that is how we start with plan and code. We use different tools like Jira and Confluence to document everything. We'll have that everything documented first to understand what are the changes, what are the features, or how we'll do it, what are the best practices. Everything will be documented there, and from there, we'll start with the development cycle. And development cycle will start with the code. It starts from Git strategy to GitOps. It can go up to that, and how that is managed, how the security is managed, even the env variables which we see regularly should not be publicly available. It should not be deployed. Yeah, I mean, committed to the code repositories, and it should be properly handled. Security is something which we need to look at even when we start in the initial stages itself. So we have to have a proper plan. Either we have to use, if we are using Git, we can use Git crypt or something like that to uh, make sure the secure files are managed properly. And there are different solutions. I'm just giving you an example here. And then the next phase would be to build and test. The build and test will be like, uh, we will have different stages where different environments to validate the code, as well as the performance and the reliability of the code. So it starts from, let's say, from the developer machine to the production stage, or the production environment. In between, we'll have different stages, like we will have a development environment. There will be a staging environment, the user acceptance environment, or quality assurance environment, and then we'll have the production and the whole cycle of automated compilation and then deployment along with the validation. It could be starting from basic code analysis tool to even the UI UX can be validated using Hapo like tools, and then we have other tools to evaluate the performance like K6 from Grafana. It could be JMeter or any other tool, the Selenium, or I believe the Grafana Cloud is also a good option to validate, because we have real user monitoring in there, and all the other different features. If you look at Grafana Cloud, you can get a clear picture of that. And then the last stage would be to deploy and monitor it. It will help especially to understand, once we deploy into the respective environments, we can validate the application, and we can continuously track the real-time performance. So for that, we have to have a proper observability platforms like Prometheus, Grafana, Loki Stack, or ELK Stack for the log monitoring, and any other tools like New Relic or any other APM tools to see how the application really performs. So once we get to see the performance and how the application is properly working, or if they are having any hiccups or any other particular errors or any problems, then we can actually go back and do the same thing. Start from the initial stage of code. We'll write the code again, build it and deploy it, and then revalidate it, and then we monitor it again, and then the cycle continues. This is what the DevOps loop is looking like. And this will also have the operation part where the SRE team will come in, or the managed services come in, and that team will be mainly focusing on the reliability and the performance of the environments. So this is how, or this is what DevOps culture is all about. And the loop, if you have seen that loop, that you'll understand it properly. So let's see how this actually matters for a business from the business standpoint. So how many of you are actually new to this DevOps and this culture? Can you drop in a message in the chat box? If anybody is from the business perspective, if anybody is having that kind of experience, can you put in a message in the chat box? Let's see how this actually matters, if if this is actually important, how this is important for the development, for the business. Um, so why do the business, actually, why should actually business should look for DevOps? This will actually help the overall cost to be reduced. There will be scenarios where the deployments or the manual fixes, everything goes in very slowly. So if there is an issue or a hot fix is required, it'll take time to develop the code, and then manually fix it, manually deploy it, and manually verify it. So everything will take time. So this is going to burn money. DevOps, will put an end to this, because DevOps will automate most of the deployments, the validation stages, and promotion from lower environment to higher environments. It will be automated. So this will overall, reduce the engineering cost, and this will improve the overall cost, incurring for the business. This will also make the customers happy, and there will be there will be different stages where where we have features ready, but it is not being properly tested across different environments, or different features are not validated, and this will take a lot of time. Either they will say that it is working in the development environment, but not working in UAT or the production level. When we go there, there will be bugs and lot of other problems happening. So that is where the DevOps and the Dockerized environments come in. This builds are faster, the QA or the quality analysis is faster, the deployment loop is getting faster. The competitors, the if the competitors are really using the advanced features and advanced methodologies, then the businesses will actually fail to get in more customers and revenue. So this DevOps culture will help them to get to the market faster. And there will be a lot of scalability issues and bottlenecks. So there will be better features where the competitors are ready to deploy, or already there in the market, and we are struggling to deploy it and test it, and those kind of things will be there. maybe it's talking the environment or the IT, the infrastructure which is behind the behind the picture, and this will possibly drain and will become a bottleneck for the business to scale. So DevOps and the SRE comes into play, and they'll help to retain customers or expand new features or onboard new clients. So everything happens because of this automation and all those things which we mentioned earlier in DevOps. And now the most important thing which will help is to reduce the production risks and other problems which we face regularly, because if we don't have clear picture on what the production environment or how the production environment is performing, then we might not understand the possibility of having a risk, or there will be a lot of other disasters which can happen in the production environment. So we should have a clear picture. For that, we have observability like Grafana Cloud is there, Prometheus, the New Relic, all those things. Instana is there. So all these tools will help us to understand and see how the infra is performing, and probably we also will introduce GitOps into the whole process, where everything goes in as code from the application to the infrastructure. Everything will be based on code, and there will be RBAC enabled. So everybody will not have access to the production environment. Only if they want to make changes, that has to go through code itself. So everything is tracked, and this will reduce the risks and disasters. Overall performance and the security will also be improved, and everything is automated. So that is one of the key important thing. And this will also improve the overall experience of customers, and that will help the business to retain customers and onboard new customers as well. So these are the reasons why DevOps is also important for a business standpoint. Okay, now let's look at the DevOps ecosystem. Um, in in DevOps, we have earlier mentioned that we'll have to design and plan everything. We usually use tools like Jira and Confluence for that, and then we move into code development, where we usually use Git or the version control systems like Git, GitHub, Bitbucket, um, and all those things will help us to we should have a proper strategy for that. There'll be different kind of strategies based on what kind of infra you are building. There'll be like code microservices for different repositories for microservices, and repository for maintaining the infra side, like Terraform code and all. So based on what and how your infra is built and designed, we'll have code bases. We'll have proper code review strategies implemented there, and then we'll move into the build stage, where Jenkins or GitHub Actions or Bitbucket pipelines or Azure DevOps, we can use different tools for that. We can either go cloud agnostic or cloud native. Cloud native is something like Azure DevOps is cloud native. We can even go like hybrid. There are scenarios like we have deployed like from Azure to AWS. So everything is written in Terraform code, and repositories in Azure repo. Azure DevOps is managed. Everything is managed through Azure DevOps and deployed into AWS environment. So that is a hybrid deployment. Um, so it depends on how you design the environments, and how you design the overall architecture. And then it comes to the infra side and the deployment side of the application. It can be deployed as Docker, or then Kubernetes as an orchestration tool, which helps to deploy as everything as code. GitOps can be implemented there using Argo CD or Flux CD or similar customized or similar tools. those are a bit advanced. We are not going into that for the day. Then we have the observability tools, where where should we should have clear picture on what the infra is happening, what is happening inside the infra, inside the application. So tools like Prometheus, Grafana, and APMs like Instana or New Relic, or there are different other tools. You can look it up, and these will help us to actually see how the systems perform, and we can improve it over time. So this is the ecosystem of DevOps. Like I said earlier, the infra is a main component where the DevOps play a major role. Rather than focusing more on the code, we work on code means the application code. We rather work on the infra as code. So that is where the IAC, like Terraform, comes in. Terraform code is an example. If you look at AWS, we have CloudFormation, and similarly for Azure, we have um, ARM and biceps enabled ARM. So there are different other tools in the market. Uh, so based on the IAC, we for example, if it's Terraform, we write the code, we make it version controlled, and we make it portable and repeatable. So that is where the platform engineering also comes in. Will have a standard, so we'll have a structure, we'll have a modularized structure, so easy to replicate among different environments or different projects. We'll have a properly designed system there. Okay. That's where we uh, make use of standardizations as well. And then we eliminate it works on my system syndrome. Usually it happens because in the earlier or the traditional ops, that a period of time, everything used to be, developed in developer's machine, and it works there, but it will not work on the production environment. So that's where the containers come in. The containers will help help eliminate this, and it will work everywhere. It will not make any problems if it works on the developer's machine. It should work exactly the same on the production environment as well. So that's how we usually do the infra development. And if you look at the infra as code, we have different standard procedures to do that. Terraform, either you can use cloud and um, the older methods of having it in the regular Git repositories. Uh, so it's something which we have, and it will be standardized, and we can reproduce it across different environments and scale it without a problem. So that's how it helps in the ISE. And the GitOps is also one of the culture where we manage everything through Git, version controlled, and the RBAC is also controlled there. So nobody will make changes in the infrastructure. Everything goes through code only, and it can be monitored. Now, let's look at the observability playing, or the incident response teams, or the SRE teams, or managed services teams responsibilities. So here, this is also a part of the DevOps culture, where we implement all these tools, which will help the other team to really do the analysis to understand what happened during an incident, and how they can recover it, or how they can improve it over time. Okay. This, I've just divided into three different columns, and so you can have a look at it. The initial point is to have everything tracked under a particular, all the matrices under a particular system, where it can look at the system level health. It could be CPU latency, network latency, the error rates, or anything related to system health. Then there will be application related, or like if you are using application or application performance monitoring tools like Instana, we'll have more clarity on what and how the application is, how that application is performing and how that is helping the system or the business. And we'll have synthetic monitoring as well as the real user monitoring there. And we'll have a particular set of thresholds, to understand how the system work. We'll have the performance performance test already done, and we know where the breaking point of the systems are, and we'll have proper threshold set up. So this will help us to reduce the noise, and will get the actual alerts which are really required action. We'll have to action them immediately to solve the problem. All right, so that very I think we stopped at monitoring tools, right? So we implement that, we'll get that matrices, so everything will be there in our uh, tool, but it might not be easily readable, or properly, something which we cannot relate to. So that's where when we create the dashboards. For example, if we go to Grafana, we'll have different um, data stores integrated into Grafana. But if there is no proper dashboard, we might not get to understand what the matrices are, or where the event started to happen, or what triggered the system to actually make a problem, or the cause and the effect will not be properly identified. So we create dashboards where everything will be defined, and we can see it properly through the dashboards. We'll understand it for a period of time. We can either look at it for 15 minutes, 5 minutes, 1 minute interval, or for a week or a month, to understand the proper changes, or if there is any particular pattern across the period of time which we are looking at. So that's where the observability and the dashboards come in. All the events, logs, and matrices can be tracked. For logs monitoring in Grafana, we can use either uh, you know a Loki stack with Promptail or with Alloy. Or we can either use ELK for log monitoring. Splunk is there. There are different tools for that. Okay. Uh, and for the recovery and automation, or the incident responses, we will have to have proper solutions. We'll have run books, we'll have rollback plans, and the failover, or the disaster recovery. We will have disaster recovery planned, or the environment defined, where everything can be monitored and the incident will be properly addressed. So DR is a different topic altogether. We'll have to work on that probably in a later uh, webinar. We'll talk about it. If you're interested, just ping me, yeah, or put it in the chat. Let's move on. And this is what DevOps is mainly about. These are the different topics you'll have to learn and understand to start with DevOps. Now, if you look at how this will help you to grow over a period of time, this is just an example, the career map, to make you understand where you will stand, and over a period of time where you can reach. Okay. So either you will start as a DevOps intern or a junior DevOps engineer, where you will get to understand how the environments work. What are the different tools we'll be using. Here, I'm just giving you a few examples where cloud, IAC, Ansible. We never talked about Ansible in this webinar. We'll talk about that in a later stage. And the Linux administration or the Windows administration, and then We have Kubernetes and Docker. So these are just few key things which you will do as a DevOps engineer, and from the DevOps junior DevOps or junior DevOps intern, you will start working over and over again, and you will gain more knowledge, and then you will become a senior DevOps, and then a platform engineer where you will focus on ISE and the infra, the cloud setup, and all those things. Then into solution architect, where you will make sure everything is documented properly before even when you start with the project, you design the platform, and you make sure everything is aligned with the project requirements, and then make sure it is implemented. Okay, that's how you reach the top level of principal or the solution architect or principal architect level. So these are the possible career ladder you can follow. Uh, if you have any questions, you can ask. Okay, you can put it in chat. Now, since we were talking about the tools, I thought we'll also have different planes. For DevOps and platform engineering, we have a lot of tools. If you go to platform engineering website, you can also see the platform engineering landscape, where you can you can identify these tools there clearly, and probably you can also look at the other documentation of each tool. So let's talk about the developer plane. That's where the initial the code, the development start from. We already discussed that there are different tools like Bitbucket, GitHub, GitLab, etc. For managing the version control systems. Then we have VS Code, where they actually develop. Then we'll have code analysis tool like SonarQube, and then we have artifactories like JFrog, Nexus, and all. So this is mainly focused on developers, engineering managers, and people who are like product managers. All those things, people will be focused on this plane, developer plane. So they plan, they develop, and they deploy. Not into their resources, but they for testing purposes they deploy and validate. So this is the plane at which the development or the developer supporting tools are mainly focused. And then we have the resource plane. Resource plane is where the cloud engineers comes in, or the platform engineers, DevOps engineers, SREs come in. So they focus on building the infrastructure, the cloud provisioning, or the infra provisioning. They focus on scalability, performance, and the cost effectiveness. The FinOps is another culture we will have to discuss on. Probably in a later webinar, we'll focus on that. So the key tool here is Terraform. Ansible, Kubernetes is another example for the infra. Uh, I mean the orchestration tool, and this is where the mostly the infra provisioning and everything related to the infra is happening. The resource plane, resources will be managed here. Then we have the integration plane. This is where the release managers, the quality assurance team, and the DevOps play. Uh, Most of the key tools are like CI/CD tools like GitHub Actions, Jenkins, Azure DevOps, Argo CD, Flux CD. Everything is introduced here in this plane. All the importance goes to how the automation happens between the developer plane and the resource plane. So that integration happens here, and DevOps play a key role, or the the platform engineering team play a key role here to make sure everything works smoothly, everything is tested properly, the build, deploy, test cycles are something which is managed here. Even focus on different strategies like shift left testing, rollback strategies. Uh, there are a lot of things which will happen in this integration plane. And then the last part will be the monitoring plane where people will be focused on having, you know, we should have the clear picture of how the infra or the application is performing. So tools like Grafana, Prometheus, Datadog, Neuralink, Azure Monitor, everything comes here. So the teams like SRE and the operations, IT operations and support teams will be focusing on this plane. And this the key goal is to have high availability and higher reliability and performance. This overall will help and improve the customer experience as well. So this is the you know let me show you the uh, this is what I mentioned earlier about the architecture. We sorry, not the architecture, the uh, landscape, a landscape of platform engineering and DevOps. The last plane, the security plane, is something which I have not mentioned earlier. This is not something you can focus on right now, but in the later stage, you should focus on it. Earlier, let me give you an example. Earlier, when I said the environment variables of the code has to be managed properly, so those can be managed in Azure's, Key Vault, AWS Secrets, so HashiCorp Vault and tools like that can be utilized there. So we will come back to that again on a later stage. So this is the landscape which I was talking about. You can go to platformengineering.org, I believe, and you can get the better picture of this. Okay, if you have any questions, you can put that on the chat so we'll discuss. What are the key learnings and opportunities we'll have? If we look at our today's session, we'll understand um, it mostly focus on reliability and the GitOps culture, or everything revolves around DevOps only. The automation is the main important ingredient here. We will have everything as code. That is where the GitOps comes in. Infrastructure will be as code. The automation from the developer to the environments. Each environment started from staging to production. Everything will be automated. If we can do it as containers, the reliability will be better. And if we are having the CI/CD implemented, everything is automated, starting from build to deploy and testing of the code, and the performance of the system can be reviewed using the CI/CD pipelines. Uh, you can unlock a lot of things using this DevOps ecosystem, where I've listed and mentioned most of the tools earlier. And then comes in the observability. That is where it's one of the essential part of this system. Okay, earlier it was not that important because the logs of this very dynamic environment like Kubernetes, if ports are scaling and we don't get to see that, um, yeah, the ports will not be there, right? So we can't identify the logs or troubleshoot if there is an issue. So that's where these kind of tools like log monitoring tools like Grafana, Loki, and all those things will help you. Uh, and definitely the dashboards will give us better visibility to what is happening in the infrastructure or the application. And if there is an incident, we'll get to know how that happened, and detect the issues faster and reduce the overall time to recovery. That is MTTR, mean time to recovery or resolve the issue. And most importantly, this is, I mean, DevOps is not about tools, it's about the principle and the culture which we focus on. That is to make sure everything is automated, scale along with the technologies are changing rapidly nowadays. So we have to move that fast with the infra changes or the application changes. Everything has to be addressed immediately. That's where DevOps comes in. And if you look at the opportunities for learners from beginners to associate to professionals, there are different levels of opportunities. And for that, what you have to do is you have to learn Linux, starting from Linux and Windows. But Linux is the key important thing you have to learn. Git, the basics of Git and version control, and the CI basics should be properly. You have to understand that to move forward. Okay, this is the beginner level of things which you need to do to properly start with your career. Then you will have to understand what is containers, how that is created, the YAML pipelines, and these are key things you need to understand to have in the junior roles, support roles, ideal for freshers and non-IT who are keenly interested in moving into IT sector, especially in DevOps. And then if you are moving into associate level, then you will have to make sure that you understand what is infra as code, Terraform, Ansible. Then you'll have to learn more about Kubernetes, cloud deployments. It could be from small to medium level of experience in these tools. Okay, then you can move into professional roles where you will have more knowledge in GitOps, advanced Kubernetes, the scaling designs, the rollbacks, what happens if a disaster hit, how should be the DR environment designed, should it be just active active or active passive or pilot, or what should be the RTO, RPO. All those things should be understood properly to move into the professional level of to get the professional level of opportunities. So there are different levels. You need to learn a lot of things to reach there. The best practices should be implemented there. The security should be addressed, and there are a lot of things you'll have to do when you move into the professional level or the architect levels. The key things to learn is AWS cloud. The cloud certificates are there. You can have a word with the Edubex team to understand what are the opportunities or the sessions they are providing for this DevOps related classes. Like I said earlier, it's not about a tool chain. It's a mindset or a culture which we evolve over the time. It has got that IT operations, the shifts cultures, and the improvements we got over the period of time with better tools and better implementation, the automations and time saving methods. This also improves the business outcomes, and the customer experience will also improve when we deploy DevOps culture into the ecosystem. So always remember, DevOps not is not a tool chain or anything related to tools. It's about a mindset and culture which helps the IT and the business to improve and minimize the overall issues. Okay. Now, the next steps you can do is, there are two different challenges where you can actually work on. You can take a screenshot of this and you can work on it. And also, if you want a handout or a PDF about all these things which we discussed, you can get it through the forms. You can scan this QR code and give in your details, and we'll send you the PDF or the handout which you can refer in the later stage. Okay. And focus on creating these challenges. The first one is to create a simple web app. It could be either 2-tier or 3-tier web application. You can simply containerize it and deploy it. Um, you can either use Docker Compose, or it could be like a mini cube, and deploy it. And in Kubernetes, you can deploy it and share it in LinkedIn, and make sure you use these tags. Okay, then only we'll get to know it, and we can give you suggestions and feedbacks. Also, the challenge number two is to build a proper full CI/CD pipeline with automated container deployments. You can use different tools for this. So create this, put it in LinkedIn, and tag us. So we'll review it and we'll comment it, and we'll help you grow. Okay. Anything else you have to ask, or if you have anything to actually discuss on, we have 5 more minutes for that. You can put it in the chat and we'll discuss.